Hello, this is Mr. Wynn, and this is about systems of equation word problems and solving systems using RREF. So, when a problem set up for elimination, meaning it's in standard form, the coefficients or numbers can be organized into an augmented matrix, which can then be put in the calculator and solved through a method called RREF, or reduced row echelon form. And when you're creating that augmented matrix, the number of equations will be the number of rows you have, and the number of columns is always one more than the number of rows. Here are the steps. As you can see, you keep going back to second matrix a lot, kind of similar to when we went back to the stat menu over and over again. You just keep going back to the second matrix menu, but make sure you memorize it because this is not provided to you. And here we'll do a problem. So, if I had this system, two variable system, two equations, we could solve by doing substitution or elimination by hand, or if we have a calculator, we can let the calculator do elimination for us using RREF. So notice that this is set up for elimination. The A's are lined up, the B's are lined up, and the answers are lined up. I can organize this into an augmented matrix. Because there's two equations, there's going to be two rows. And because there's two rows, there's going to be three columns. I like organizing columns. I'll call this the A column, the B column, and the answer column. But the first equation goes in as so. There are 10 A's, there are -3 B's, and there's -34 is the answer. Second equation, 3 A's, +8 B's, -28 is the answer. That's my augmented matrix. I'm going to type that in my calculator. So, put my calculator, tab. Alright. You're going to press second matrix right underneath math. Go right twice to edit. Press enter. There's 1 by 1, that's rows times columns. There's 2 rows, so 2 enter, and 3 columns, 3 enter. You fill in the numbers, so it goes 10, -3, -34. And on the bottom is 3, 8, -28. Once you type it in, you have to quit and go back to the main screen. So second quit. Now go back to matrix, second matrix, go right to math. We're going to go up to B, RREF, there's 2 R's. Press enter. It's asking what they want the calculator to do REF of. Go back to second matrix one last time. Picked A. That's what we were picking. Press enter. And the calculator gives us that. The make sure you write down what the calculator tells you. So this says 1, 0, -4. 1, 0, -4. 0, 1, -2. So the calculator gives you back the reduced matrix. But it matches the same order. This is the A's, this is the B's, and this is the answers. Make sure you read or change the calculator's matrix answer back into equation form. So this means 1A plus 0B equals -4. Then 0A's plus 1B equals -2. Notice it tells you what A and B equals. So that's our answer. This answer is -4, -2. Alright, so again, you make sure it's in elimination form. The A's lined up, the B's lined up, the answers are by itself on the side and lined up. You make the augmented matrix, you type in the calculator, REF that, and you get A and B. So down here is a triple system. We could do it by hand again, by substitution elimination, but it takes half the page. We can do the calculator, it's much faster. So let's first make sure they're all lined up. The X's are lined up, the Y's are lined up, the Z's are lined up, the answers are lined up. I'm going to create the matrix. There's 3 equations, there's 3 rows. There's going to be 4 columns. I like label them, so this is my X column, my Y column, my Z column, my answer column. I'm going to fill it in. For the first equation, it's -5, 1, -4, 60. Second one is 2, 4, 3, -12. The last one is 6, -3, -2, -52. Go to my calculator. Type it all in. So again, second matrix, edit. It's now a 3 by 4. Type in all numbers, -5, 1, -4, 60. 2, 4, 3, -12. -12. Then 6, -3, -2, -52. Then quit, second quit, back to second matrix, math, B, REF, second matrix A, calculates us this, so make sure you write it down. So 1, 0, 0, -8. 1, 0, 0, negative 8. Second one said 0, 1, 4, 0, 1, 0, 4. And the last one said 0, 0, 1, negative 4. Alright, and this is the x column, the y column, the z column, the answer column. We write this in equation form. Very important. The first row says 1x plus 0y plus 0z equals negative 8. So we know x equals negative 8. Second row says 0x's 1y plus 0z's equals 4. The last row says 0x, 0y, but 1z equals negative 4. And remember, our answer is a coordinate ordered triple. So it's negative 8, comma 4, comma negative 4. Again, this is consistent, independent. That looks bad. Fix that. Alright. So like before, sometimes we have infinite solutions and no solution. The calculator also tell us when that happens. Just read the equation from the calculator carefully. So this first one is set up, x's, y's, z's, answers. I'm going to create the matrix. It goes negative 2, 15, 1, 44, 4, 3, 3, 18, negative 3, 6, negative 1, 8. I'm going to type it in the calculator. So second matrix, edit, it's 3 by 4. 3 by 4, enter, enter. All right, negative 2, 15, 1, 44, 4, 3, 3, 18, negative 3, 6, negative 1, 8. Quit matrix, nope, 100% miss matrix. Second matrix, math, B, R, E, F. Second matrix, A, gives me this. Now notice it gives me 1x plus 0y plus that decimal z equals a number, which is weird, equals 0. And the second one gives me 0, 1, and a number, so 1y plus that decimal z equals 0. The last one's the most important one. It says 0x plus 0y plus 0z equals 1. So can we have 0 equal to 1? That's false. For true, if you see a lot of decimals, and you just don't see lots of ones and zeros, it's going to be no solution, infinite solutions. It depends on the third row. But you read it. If it's false, you say no solution. Inconsistent. If it's true, you say all rows numbers, infinite number solutions. Consistent, dependent. So let me try this other one. So down here, my first, it goes R's and S's and T's. So 1R, negative 3S, 1T equals 4. 3R's, negative 6S, 9T equals 5. 4, negative 9, 10, 9. Type this in my calculator and see what I get. So second matrix, edit, 3 by 4. That is positive 1, negative 3, positive 1, 4, 3, negative 6, 9, 5. Alright, so typing the last numbers, the last row is 4, negative 9, 10, 9. Second quit, second matrix, math, REF, second matrix, A. Oops, I missed it. Second matrix. Second matrix, math, B, REF, second matrix, A, enter. So again, I see 1R plus 7T equals negative 3. Second, usually you don't have two letters, you have one letter. Second row, second equation says 1S plus 2T equals that negative 2.3 repeating. With that last row, again, we see multiple letters. Check the last row. It says 0R plus 0S plus 0T. 0 equals 0. When you see 0 equals 0, that is true. That's infinite. That's all infinitely many solutions. All right, and you could say consistent, dependent. All right, now that you know how to solve every system really fast, efficiently with a calculator, REF, you need to be able to create the word problems. When creating a word problem from an equation, make sure you use common sense and follow a theme if possible. So here's a couple. Write the system of equations representing this situation. Hannah bought 2 burgers, 1 hot dog, and 1 drink for that much. Denise bought 1 burger, 2 hot dogs, and 2 drinks for that much. Elena bought 2 burgers and 2 drinks for that much. So this is the theme. I say separate each person, like options. So the first person bought 2 burgers. I'll say B for burgers, plus 1 hot dog, plus 1 drink. That equals $8.50. The second option was second person bought 1 burger, plus 2 hot dogs, plus 2 drinks, and paid $9.50. The third person, or third option, bought 2 burgers, plus 2 drinks. Now be careful, there's no hot dogs here, equals 9. Alright, we now have the equations. You could then put that in the calculator, or turn to matrix, put in the calculator, and let it solve for you. Or you can do it by hand, but it takes a while. That's it. Another theme could be this. Ashley has 20 coins in her pocket, consisting of quarters and dimes. The total value is 305. The themes here are total coins. Since they're quarters and dimes, I'll use Q and D. But the number of quarters, for example, 5 quarters plus the number of dimes, say 10 dimes, is the total coins, 20. There's no money signs or any value yet. But then they say the total value of the coins is $3.05. Now we add the value of each quarter in every dime. Every quarter is worth 0.25. So there's 5 quarters. 5 times 0.25 is $1.25. Every dime is worth 0.10. And then the money price, the value is $3.05. So all the money signs go in the second equation. Right? So from there, that standard form, you can put in the calculator, REF that, after you make it a matrix, of course. There's another one, it could be harder. Mary Beth has 97 coins in her pocket, nickels, dimes, and quarters. Total value is $10.70, and there are 2 more dimes and quarters. So there's 3 things here, so 3 equations. It's a triple system. We still have the total coins, because there's nickels, dimes, and quarters. We say the number of nickels, the total number of nickels, plus the total number of dimes, plus the total number of quarters, is equal to 97. Money value, a nickel's worth 0.05, 5 cents each. A dime's worth 0.10, 10 cents each. You actually don't need a 0 there. And a quarter's worth 0.25. And the total value is $10.70. That's the second equation. The third theme is the common sense theme. There are 2 more dimes and quarters. The way I write this is I'll say the 2 things are comparing. They're comparing dimes and quarters. I'll put an equal sign between them. But they're not equal. One of them's obviously bigger. Because there's 2 more dimes than quarters, we know there's more dimes, there's less quarters. So the 2 more, the plus 2, has to balance the equation. If there's more dimes, then I shouldn't add 2 more to that to make an even bigger number. I should put the plus 2 on the smaller side, the quarter side. So the number of quarters plus 2 equals the numbers of dimes. Alright, so that's the third equation, but you're going to have to fix that before you put in the calculator. You have to get in standard form. So remember, all 3 of the equations must be in standard form with the letters on the left lined up in order and the answer on the right. So I'm supposed to actually subtract Q from both sides here and get the real equation of D minus Q equals 2. That's this one, and this one will be used in the calculator for the matrix in REF. Alright, but that's the common sense equation. Make sure you write the 2 things you're comparing and then put the plus or minus on the correct side. Help the smaller guy. Don't help the bigger number. Alright, and the last one, here's another one. Admission fee for a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people entered, and 5,050 was collected. So the 2 themes here are total people. We can call the first one children. So C for children, the number of children plus the number of adults is 2,200 people. There are 2,200 humans there. Some of them are children, some of them are adults. Then we have the money stuff in 1. Each children paid $1.50, so 1.50 for every child, plus every adult paid $4 per every adult, so there's 10 adults, that's $40. And the total amount collected was 50/50. Alright, we now have our equation. They're both in standard form. You can make that a matrix and type in the calculator. And that's it. Just make sure you read carefully. Again, thanks for watching. See you in class. Any questions if you have any. See you soon. Bye.